Hello, welcome to a tutorial for splitting to subvolumes and manipulation of regions of volumes in microscopy nodes. This is the idea where you can take part of a microscopy volume that you've masked out or that you've isosurfaced out and transform it separately from the rest of the volume. This requires a little bit more skill in the programmatic operation of Blender using geometry nodes, which I will explain along the way, but I would recommend that you watch some of my other videos on masking and loading before you try this one. So now we've deleted everything in our scene, and I'll put in a data set for a meiotic-nucleus through time. The URL for this will be in the description. And this is quite a small data set, and this is nice to kind of show off the capacity of this kind of modulation, because it can take a lot of time when you have very high resolution data, because you're sampling and regenerating the volumes on the fly quite a bit. For now, I first will just start where we're going to get the volume of the synapse-nemo complex and the volume of the crossover marker, and then we'll get the surface of the synapse-nemo complex as well. So we're going to take the surface and then split the original volume by by that surface. And here we have that loaded. This might take a little bit of time because it's a time series. And we can now go into the geometry nodes and add nodes such as mask grid to make separate, to mask out based on our surface. So this is if we don't want to move things around, like manipulate our regions. This is one of the easier ways to do this, where if we now turn off the visibility of the surface, we can see that we've masked our data to that surface region. However, what I now want to do is I want to be able to manipulate these separate regions. And for that, we don't want the mask grid node. We want this node called split to subvolumes. So this also takes a grid, which is the volume data that will be sampled to each of the subvolumes. And this has a voxel size, which is the size of the voxels that each of these subvolumes will be assessed at. For now, I'll already set this a bit lower. And the other input that this gets, that's quite important, is the mesh instances. So the mask grid can take a mesh. So if we pull in the surface, the geometry output here will work into the mesh input in here, because this is a single mesh. However, what we're working here is mesh instances, so we need to have separate instances of meshes. An instance is just some Blender jargon for a list of objects, effectively. It is not exactly a list, but that's a little bit detailed. But what we can do is we can add a split to instances in between here. And I'm going to just set this back to object. Split to instances, and then we can add mesh island, which is the index of which separate region of the mesh it belongs to. So this is essentially splitting all the non-connected components. And then we'll have an instance for each of our components. So we can also see if we put this into the geometry, we'll get a separate mesh instance that comes out of the volume for each separate object. So we'll also get this, for example. But if we reset this, we can now also put the instances into our split to subvolumes. And what we'll then get is, again, separate instances, but each of these has a little volume grid. And that volume grid is sampled from the original synapse-nemo complex data grid. But because these are subvolumes, they don't really do a lot, as they're not very useful to use in this case. So we want to actually get back from our subvolumes into combine channels, merge subvolumes to grid, and then we can just put that into as a normal channel, because then it is just, again, a single grid. And then we'll see that we have our data here. And here again, we want to set our voxel size a bit lower, because that's the voxel size that that last grid gets evaluated at. And then we just have our subvolumes. So in between here, we have separate volumes. That means that if we want to do set position, we can move our subvolumes. And I will make the slice cube a bit bigger so that we see this a little bit, so we have more range. You can see that we can move our synaptonemal complexes, but the cool thing about these being subvolumes is that we can now say that each of the instances that we put in gets its own little volume. And that means that if we do greater than, I'm going to remove this with X. If we add a greater than node based on the index, and we put that into the selection, we can say I only want to do the move action on those where the index of our instance is high enough. So now we can see, I'll go back to this actually. We can see that only some of these get moved. And I think more interestingly still, we can also do combine X, Y, Z. And I'll remove the greater than. And we put the index into our y-axis and put this as the offset. And then we can see that they're all moved by the amount of this index. And this is a way that you can just start separating and manipulating all of these separate internal regions individually. And you can make your own kind of math around how you want to animate and show these. There's different applications for this kind of process. One of them would be for sorting things by type or identity. Another is to make things explode, so make them move away from each other so you can show contact areas. And another way is where you start with an internal region that you can kind of assemble all your tissue together to kind of show scale. And this is usually this is a way that we can add extra dynamics and sense of scale to our animations, even if it is not the easiest thing to just set up. It can yield very beautiful things. So right now what we want to get is our actual labels in there. And this dataset includes, so I'll turn off the surface and add the masks of the chromosomes as a label mask with a categorical color map just for easier viewing, where we see these here. And these are actually already instances that have as their name and as a value on the instance domain the tracked identity number that they had in the original array that this is pulled from. So if we now replace our surface and instancing, so I'm going to remove this with X and put in our label mask. We can put these mesh instances in instead. And we can multiply our index a little bit. Why is nothing happening? And we can reconnect the thing here. We can see that we now have all of our 6 chromosomes, and we can, with this multiply, scale how far they are along this axis, and we can also animate this thing. And this is the actual data, which we can see, I think, a little bit better if we also apply this to the crossover marker grid. And here we can see all of our individual chromosomes separated, and we could easily animate just this one value by setting some keyframes and start from 0 and extend this out to have each of our separate chromosomes. So this is really cool and can really yield really interesting animations. However, currently we're still basing everything on the index. So if we're going to go through time with the arrow keys, we can see that they actually flip because the index is not defined. The only thing that we have defined is our object identity. So we want to capture an attribute from this. So this is a little bit more advanced. Again, you've seen how the how to just be able to tear these things apart based on what they are, but now we want to actually use the object identity to define their position. And for that we can do capture attribute. So we need to pipe that through correctly and say named attribute OID. And then we can here read out the attribute. However, this is going to be quite high because these this data set has like up to 1500, and we don't want to multiply the size of the grid by 1500 because this will be this will try to make a grid of a full volume of that size, and that will be very heavy on the computer. So I'm first going to do another multiply that is quite low. And then put this into our, actually I want to put this in here, and we want to have this not on the point domain, but on the, this is an attribute that exists on the instance domain. So now we have the same thing, but it will actually have all of our separated masks through time. So here we can see the, wait, under me we can see the time, that we actually have the right tracks, and then we always see the right synaptic complex in the same spot. And then this is still animatable. However, if this is too finicky to kind of figure out with all of these multiplications, the other way that you could do this is by making your own little CSV, where you just match your object identity to the location you want to have them, and then you can do import CSV in here as well, where you can point to a CSV path and use these same kinds of capture attribute nodes and named attribute nodes to get the object identity and to match the object identity to the final position, and then you can just scale that. So I hope this is helpful, and I hope that people can use this. Again, there is the point where this essentially will make a giant grid at the end, so once you're kind of done, I would set the voxel sizes even smaller so that you know that you're not distorting your data, but this can make everything a bit slow to work with, so I would do that only at the end. And especially with larger volumes, this will take a little bit more time. With this kind of process, we make quite a complicated tree. This looks a little bit overwhelming at the end, but in the end, it is not completely strange. We're just loading our data, splitting it to subvolumes based on mesh instances, and then setting the position based on a captured identity attribute, and then merging them back together, merging them, and then we just have our normal default end of this, which is merging the volumes, joining them into a stack, and setting the material, which is just setting the shader correctly. Okay, I hope this helps, and I hope that you're able to make subvolumes. Please let me know if it doesn't. I'm reachable through ImageSC. And if you do want help with this, please just send also a screenshot of your node tree and make sure that you're at least on 3.1.2 of microscopy nodes, because the subvolume things were not working in 3.1.0.